So, first of all, it's nice to see you all. It's my first time to Novosibirsk. It was a pretty long journey here, although I'm from Ukraine, but well, it was too many flights in one day. So, if I will be telling some weird things, I think it's the main reason. So, first of all, today, and it's important, I have many different activities. I teach JavaScript, I run local Kharkiv JS community, but today I will be speaking as the founder and CEO of Buccal Labs. This is my company, which is existing already for 5 years or so, and we are focusing on just one thing: we develop with JavaScript. We call that One Love Forever. My imaginary psychiatrist probably calls this Stockholm Syndrome. Well, in general, it will be 12 years or so of developing with JavaScript for me personally. Yesterday, preparing this talk, you know, this talk like a lazy promise, so you promised organizers you have a talk, arrive and finish the talk just in time. I've checked the website, and one of the biggest projects I've done 10 years ago is still alive, working and earning some money. So it was a long way, and you know, everything that happened on that way, every new JavaScript framework, each week, changing everything, every new approach with several months, and so on and so on and so on. And well, if you live so long with such an ugly language as JavaScript, you need some tooling to help this. And this tooling I was building step by step. It's pretty common. We have ESLint, which is a tool which helps us to prevent some ugly things. We have Prettier, which helps junior software developers pretend they're styling code like the senior ones, and simplifies code reviews, simplifies everything. And we speak about Flow because, well, everyone needs type system. I do not love TypeScript at all because the TypeScript is weak, is ugly. I can talk a lot about it, but this is not my talk today. But this is not enough, because the tooling can't help that the JavaScript does not make you fall into the pit of success like, for example, Python do. You need approaches which helps you to build maintainable code with this ugly language. So, you know, there are different approaches which roam here and there. For example, everyone for last maybe couple years speak a lot about functional programming, functional reactive programming, which is a common approach to simplify your code. I have a mixed feelings about it. Actually, everything goes well when I'm writing small pure functions, but when it comes to some complex side effects, it looks like, you know, if you are the big fan of Doctor Who, it's the main character was explaining how time travel works, and it sounded like wibbly wobbly, timey wimey, and this is exactly way how do I describe how I perform side effects in my pure functional code. That's why the functional programming it sounds like a silver bullet, but it is not. I have a small company of persons who do not have a degree in mathematics, who does not even, some of them have degree in computer science, and to explain all that monad things could be a pain. You know, from my point of view, it looks like when a person understands how monad works, it automatically loses an ability to explain that. And this is a real trouble. Another common approach which greatly helps us to build a reliable code, which greatly helps us to build a good tooling, is immutability. You know, they say that functional programming language books does not mutate your brain, they provide a new one. This is exactly the way everyone loves, for example, immutable JS. Well, we use it from time to time. Sometimes we use a flow which provides the same functionality with covariance, contravariance, and whatever. If that word sound new for you, don't remember them. But this does not solve the main problem. You can do whatever you want. You can take different approaches. You can build tooling on top of this language, but you still have such problem, which is taken directly from examples of flow. You have a method which does something. Let's assume we know nothing about it. You have another method. You see I'm good at naming the same as flow authors, and which accepts the object which may or may not have the prop of string type. At the line 5, I verify that value prop exists, but at the line 8, the flow will complain that it has no guarantee that value prop exists. Why? I verified it. This is because the JavaScript has tons of ugly approaches, has tons of different possibilities, and flow can't guarantee that other method didn't modify the object. So, between this check and this code, there is a possibility that this method modified the value, and the prop may be invalid. This is the main reason I love flow flow over the TypeScript. This is because the flow assumes that a software developer is evil, and the TypeScript trusts software developer. So this code will work okay for TypeScript, and the flow will complain and make you suffer. But the problem still persists. It's annoying. It's unsound. Soundness is the perfect word which does not have a nice translation to Russian, but that is greatly involved when we speak about type systems. So this is the pain. And this is the pain even for Facebook, which are one of the biggest JavaScript community consumers. They have one of the largest JavaScript code bases in the world, even bigger than Google one, and why they developed all that tooling? Why they developed React? Because Facebook chat was slow. Why developed Flow? Because their code base was unmaintainable. So the Facebook suffered from the same problem, and they wanted to solve it. But before we speak about Facebook, let's continue our time travel. I've touched a lot of frameworks. I know it's a big thing to call jQuery a framework, but while 10 years ago it probably was. It is also a big thing to call the React as a framework. It's just a view layer, but whatever. I've tried different things, and if I put everything I tried for these 10 or 12 years, there will be no room on this slide at all. But there was one thing in common. That thing was everything was in JavaScript. Okay, I am not fully fair with you. I've tried CoffeeScript a bit. I didn't like it at all. And even with the release CoffeeScript 2.0 now, I don't going to try it again. But the Google came, and this one thing in common changed. One of my main benefits of my customers is that they're usually non-technical persons. They usually do not care about technologies we pick, about approaches we use, and as soon as we deliver business value, they do not care. Our clients are pretty varied, like United Nations, UNICEF, and whatever, Microsoft Mobile. They also do not care about what technologies do we use. But here, once the customer came a request to help their friend or whatever, and they wanted Angular. Angular 2 or 4, I don't remember that numbering, but I was forced to use TypeScript. Okay, I know you can use Dart with Angular. Yes, I know that you probably, they say, you can use pure JavaScript, but this is a pain to use a JavaScript with the Angular 2. It is not documented. It seems like, okay, never try this. But what I realized, I no more writing a JavaScript code. But after that, after this project, which was a big pain for me, after this project, I like Angular 2 no more. I realized one more big thing. Actually, I was doing the same for pretty long time. Since we are using Babel, we are not writing in the JavaScript way we are running in browser. We actually are building our projects on the other language, which looks quite similar with JavaScript, but it is not actually it. What stage is enabled in your project? For last year, I was talking at a lot of conferences, and I was speaking, do not use JavaScript decorators. They were stage 1 when they became popular, and now they're stage 2, and the spec changed totally. Stage 1 and stage 2 version of decorator specifications are totally incompatible. So were you using the JavaScript? No, because that was a somewhere thing which will not become a standard. And as soon as you realize that, as soon as you discover that traveling from project to project in one company or in many companies where I'm involved as expert, you realize that you have actually a variety of choices. Which language you want to transpile into JavaScript? Will it be the JavaScript stage something with some new cool things? Probably you like private fields. Probably you like do expressions, whatever. Maybe you like TypeScript. So who likes Microsoft, whatever. Or you like Google, so you pick Dart. Or you are more like a hipster, so you pick Elm, PureScript. There are a lot of things here. And here where Facebook comes in play. Of course, when Facebook discovered their problem, they have different options to pick. And like many companies, they suffer or not suffer, maybe they like it from niche syndrome, not invented here. So if Google have Angular and Dart as a programming language, Facebook needs to have their own. And they done it. It's called Reason, but it's not that simple. Before we understand if the reason is a hype or something really important, we need to go a bit deeper and understand what a reason is. Actually, Reason is not a programming language. Actually, when we speak Reason, we're speaking about a camel. Well, I have one useless thing my parents are very proud of. This useless thing is PhD in computer science. Absolutely useless in my profession, in my activities. But when I was developing artificial intelligence related things and data processing things for my PhD, I was extensively using a camel. Why a camel? Why Facebook paid attention to it, and why it may be interested to JavaScript developers? Well, every talk must have an ugly slide with bullets. Here it is. First of all, a camel is a functional language, but it has immutable values. All values are immutable by default. It has strong static typing, allowing you express things. And since everyone is lazy, and this is another thing why I prefer Flow over the TypeScript, is a powerful type inference. Ability to infer types when you are writing 0 types in your code. And the fourth, the last one, but the not least, is the algebraic data types. For persons who are not familiar with typing with TypeScript or Flow, that means that you can say this type is this type, and or using a common mathematical operators to express relations between types. That's called algebraic data types. And pattern matching, we come to that a bit later. Also, why Facebook took a look into a camel? Well, I think this is a coincidence. It is a perfect coincidence that at Facebook some time ago was a group of developers which were fond of this exact language, which is functional, which is nice, but, and it's a very important thing, people who developed OCaml has a very long history, it's 30 years old, really care about getting things done. What do I mean? What do they mean? It means that, okay, we are purely functional, we have immutable values, but if you need, you can use imperative programming, you can use for loops, you can mutate entries in the objects, because, well, you know, a lot of things are easier to express for a common person in common imperative approach than in functional one. That's why it's important. That's why, for example, we do not speak about Haskell. It's awesome, but every time when I'm trying to write something big and real in Haskell, I end with a terrible headache. Maybe I'm not enough enlightened to do that. I hope you are. So the OCaml has a very important thing for a business, which is usually not getting too much attention when we speak about language possibilities, language capabilities. It's escape hatches. It's an ability to do some ugly things while keeping the major of the code clean. Facebook has a very good experience of dog fooding OCaml. Two big Facebook projects, Hack, which is transpiled to PHP, and Flow, which adding strict typing to the JavaScript, are powered with OCaml. OCaml is extremely fast. The startup time of the abstract syntax tree parser of JavaScript written in OCaml for Flow is 3 times faster than the common Esprima which is used for Babel. Just to compare. But OCaml is also highly modular. This is one more thing which is interesting. The flow is pretty common. Yes, you have OCaml syntax, which is getting translated to abstract syntax tree. After that, we are building so-called enriched abstract syntax tree when we spoke about type inferring. So we're gathering as much type information as we can. And we have abstract syntax tree plus typing and compiler backend, and the last step translates that to the native code. Pretty trivial, yes? The common pipeline for any modern compiler, maybe Clang if you are familiar with, or a lot of LLVM based have this pipeline, but OCaml took that one step further. They have 2 different compiler backends, one for native code and one for bytecode. Why they did that? Because they wanted OCaml code to behave like write once, run anywhere. Oh, that was a Java motto. But actually, anywhere when you have where you have C compiler, you can build OCaml VM and run OCaml bytecode. Yeah, pretty obvious. And when you have such 2 compiler backends and you have a bytecode generated, it becomes pretty easy to build a JavaScript virtual machine which will run bytecode produced by compiler. Yeah. JavaScript is now pretty performant, and that will work. That will work pretty nicely, but here comes the issue. We have a typing information here which is lost, and when we have a JavaScript code being run, V8 or whatever engine is running needs to gather that information from scratch. You understand? It means determining the hot parts of your code, optimizing, and so on and so on. This information is important and can be used effectively for optimization. And here, when we transpile that into the bytecode, this information is lost. So, what can we do? We just threw away an existing compiler backend and make a compiler backend which transpiles directly to the JavaScript code. This is called Buccal Script. And, well, this is the first part of the reason. What is Buccal Script? They implemented a standard OCaml library in JavaScript and implemented the ability to transpile OCaml language constructions to the JS code. So, everyone knows, here's the left pad, you know that. NPM module implemented in OCaml. Pretty obvious, looks not so familiar for you because here, for example, a left pad size equals to 32. It is a defining variable inside this block. But whatever, defining the function, defining one more function, defining the variable, and invoking that function and passing it to the JavaScript log. Actually, this operator is actually proposed also to JavaScript, and this is stage 0 proposal. Means please reverse the function execution order. So it runs this, and after that pass the result here for better expression code. So let's take a look how it is transpiled. Well, it is transpiled to a few requires, which are building blocks from a OCaml standard library. It is transpiled to the variable declaration and to console log statement. Not so ugly code as you need. If we strip comments, it is human readable, and this is the very powerful part of the OCaml. But there is one thing which could be easily missed here. This thing is the last line. Left pad, not a pure module. By leveraging access to the typing system of OCaml, and because that type system is very strict, Buccal Script compiler is able to understand if any module is having side effects. This module is obviously not a pure module because it does console log. But if we have a pure module, Buccal Script is capable of generating code which might be unsafe from human point of view, but is safe because on a OCaml level it is proven that this module is pure. So we have a capability to provide more optimized code by understanding if this module of separate parts are pure or not. The idea of purity is the main idea of V8 optimizations, which are built inside the Chrome V8 engine, and here the same approach is leveraged. So another thing which we need to know before we proceed, that instead of building the whole project with OCaml or whatever, Buccal Script and OCaml is designed in the way to work on modular basics. That means that each file, let's assume this is one file, will be mapped to one JavaScript module. Not you pick a project and build that into the one module. No, we have one-to-one mapping, and it's up to you to how you will build that JavaScript modules. Will you use Webpack? Will you use Rollup? Will you after that proceed the code to Google Closure compiler, which will effectively eliminate that code? That will work. Because on module approaches, which is heavily a part of OCaml originally, OCaml compiler is extremely fast. It takes milliseconds to do an incremental build. If you're having a TypeScript project with a big types, you know that incremental builds can take seconds. Here it's usually 100 to 250 milliseconds for a quite a big project. And yes, I have production running in Reason already. The one last thing, which is maybe the main discussion point, is OCaml syntax. It is, let's say, not so friendly for common people. You know, let's take a look at this code to understand. Let's try to, probably if you are familiar with computer science or just visiting some coding interviews, you probably identify it. It's a quicksort implementation. but it is not so human-friendly. Arrays separated by semicolons, where double. Here we have an equal sign. Here we have a usual arrow. Pretty unfriendly syntax. At least this is the point how Facebook thinks. So what do? They say, okay, we will have reason. Reason is a new front end to a camel abstract syntax tree. It is not a new language. It's just this other way to express the same things, which will result in the same abstract syntax tree. Here comes how the code will look into the reason. So it should look a bit more friendlier to a JavaScript developer. Yeah. For example, here we have much more friendlier spread syntax, yes, which is more familiar for common people. We have a normal things like commas for separating arrays. We have a common fat arrows. So let's first, instead of word with keyword, which confuses a lot of people, we have a block scoping. Also, one more thing which is not highlighted, reason removes the requirement in a camel. Originally you have two different operators. One is semicolon and one is double semicolon. And double semicolon is required only on the root level to separate root level instructions. Reason removes that. Another change is, okay, here is important thing. Two different meanings of arrows here are translated to the same fetch arrow in reason. So reason will figure that from the context of usage, because both of them are from JavaScript developer point of view basically the same thing. This is the function declaration. We are declaring the arrow function, and this is the function which takes the argument and returns the argument. Yes, the short version of arrow functions when we have implicit return syntax. And the last one is, like we said before, the comma thing, pretty dull. So instead the camel syntax, we are switching to the reason syntax. Frankly speaking, it is this change is having a strong opposition even inside Facebook. A lot of people, even inside Facebook, refuse to write with reason. They say, we know a camel, we will stick to the camel, and well, it's the duck syndrome. The duck syndrome is that the duck is being born. The first thing it will see, it will call mommy. So you usually pick your first language is the best one, and your first framework is the best one. It's probably here. So what is the reason actually? Reason is a curated. It's a very important thing. It's a curated tooling for building things on top of a camel. It includes new syntax. It includes Buccal Script as backend compiler. It includes something like ReFormatter, which is just same thing like a preacher in JavaScript community. So the thing to pretty format your code. And since it's React, and since Dan Abramov joined the React, it's they're paying a lot of attention to be developer friendly. For example, Flow from Facebook for a long time and even now has one of the worst developer experience in terms of reporting errors. It's awful. It is the way it was the most explicit and the longest way to say the developer you are a loser and you understand nothing with type systems. Reason for a long time was the same. So it was just morning and you with a lot of words in the same thing. But frankly speaking, it's now changing. Actually, that's how the error looks. It's a whole error. So it complains about what is the source of error, what is the type what is wanted, what is the incompatible part of the type. And trust me, the last one, which is incompatible, is not so obvious with common types. And you know, the TypeScript was developed by a person who created C#. Well, the reason was created by a person who created React. So we have one thing called Reason React, which is purely awesome. Why? Because the Reason React is actually behaving now like a playground for for new possible features and new possible syntaxes, how React components might work and might look in the JavaScript. You probably don't know, but the first prototype of React.js was written in standard ML, in language very close to a camel. Actually, and after that it was transpiled from standard ML to the JavaScript, and it was after that rewritten to the React.js just to gain more traction from developers. So that's why the reason and the Buccal Script have the native JS6 support. Well, the native JS6 support is a bit ugly if you switch from the common JavaScript, because, for example, oh, I'm missing this example here, but it could be seen, yeah, it could be seen here. Since I have a strict typing, so I can nest only elements inside the JS6 elements. So if I want to put string somewhere, I need to convert it to element with reason react dot string to element. But whatever, we have a common JavaScript approach, and this is, by the way, the syntax how we define a component with React reason. We define the state type. We say please define the component, and we define a function which returns an initial state and the render. Also, we have reducers. Yes, you know that Redux was greatly inspired by Elm, and here we have the same approach. They probably greatly they said that Redux is awesome way of handling changes when you have actions and so on and so on. And that's why Reason React, and possibly, I will insist possibly, it's still a playground, have a way of creating components calling reducer component, when you are not declaring in declarative way what you do. Instead, when you have something to change in the component, you emit action. Action is just a variant. Yes, you have action. They say click toggle. It's not a string. It's just an, if you are familiar with Lisp languages, it's an atom. Just a constant. Treat this like a constant. And you say here we emit click, and we have a reducer, which is pretty familiar for everyone who runs Redux. Action state, for each action we return what to do. What to do? We have 4 options what to do. We have, say, no reaction. We can say please update the state of the component, and we can say please perform side effects. You know, some things which could not be expressed as a state update. Maybe communicating to other components, sending AJAX request or whatever, or 2 things at the same time. Yes, update state, for example, set loading to true, and perform side effects. So actually you have a very testable component with a reducer. And well, what I'm speaking about, if you're familiar with Redux, you know that reducers are perfectly testable and so on. One more thing. Redux is moving forward quite quickly, but Facebook already treats it as production ready. Why? Because messenger.com, it is the Facebook Messenger on separate domain, the main one, is already 50% written with Reason. So the Facebook is heavily dogfooding the project, and well, they even change the syntax from time to time. They will be soon at least one big change to the Reason syntax, making it look even more like JavaScript. But for each such change, code mods are provided by Facebook. So when I came to my project, which was written in Reason after 3 months, what I had, I write 2 node scripts and commit the result to the repository. Well, of course, not so fast. Since it was introduction of reducer components, I need to do some things manually to fix some warnings, but whatever. You do not feel alone. Facebook cares about keeping your code up to date with the platform. Actually, this is the very first step of Reason. The very first step of bringing a camel ecosystem to the JavaScript. What Facebook wants, if we, for example, and probably this is the main thing which will determine if the Reason thing will be a great success or not. For example, if we speak about Dart, we have a Fuchsia, right, project. If it will be successful, it's a full rewrite of mobile platform with Dart, replacing the existing Linux kernel and whatever from scratch. So if it will success, if it will be so powerful how Google is promoting it, it will be an awesome platform for making Dart blow up. Facebook is telling, okay, we have a camel which brings us very cool benefits. For example, we can, since we have a native backend for a camel, we can use it, for example, on server to perform very fast server-side renders. No more putting up Node.js to run the code. No more big memory footprints. You know that Node.js server-side rendering is pretty slow. Since a camel have the native renderer, they say, okay, we are building the React Native bridge to a camel and Reason, and we will be able to build the code written with a camel to the native code, making the most performance on the mobile platforms. So Facebook has a great plans leveraging the existing camel ecosystem, and if they will success, it will be a huge success for everyone, and I mean that the Reason will gain traction. Right now, the Reason community is pretty small and yet responsive, and it's really a nice opportunity to speak with people who created React in real time in Discord. We had an experience writing a project with Reason and Reason React. It was a success. It was a pretty understandable and nice way of transition, and it prevents us for doing, for example, there is one thing which I constantly do in reducers, the one error. That's, for example, when I have the response from the server, I need it written to the application state in reverse. I'm writing something r.reverse. And I totally forget that reverse is both returning the reversed array and doing the side effect of switching it in place. Just for example, actually there was a research 2 weeks ago or so, telling that using the type system like Flow or TypeScript have like 15% less bugs in the code. Facebook tells that they have a miracles for new messenger platforms, like they had 100 bugs before reported per 2 weeks, and like they have 15 bugs reported in 3 weeks or so since switching to the Reason code base. I don't know, maybe because nobody is using Facebook Messenger in the web. I don't know, but this is the point. We have a good platform with a smooth transition part for existing JavaScript developers, which is really important. Learning curve of Reason is really nice, way more better than pure Camel, way more better, for example, than, I don't know, Angular 2. And it is a nice and sound way to express a common approaches. The last but not least thing which we have is that Facebook is building this ecosystem to be friendly to existing code. If you don't know how to express something in a Camel in the right way, you can use a bit of dirty magic and just copy and paste the part of the JavaScript code directly in the Reason code. It will work. And this is the official way, like they say, of rewriting the existing code base to a Camel. And this is the last thing I really like, because you know that approach, we will throw everything away and write new thing from scratch will never work. I'm transitioning a big project to the Reason file by file, part by part, and it really plays nicely and helps us to catch errors. Well, that's all for now. If you have any questions, you are welcome.
Okay.
Hello, my name is Andrei. You say that you transpile your Reason and wrap it into Buccal Script, if I understand right. How it increase size of your application? And second question is, does Reason have interop with JavaScript libraries like Lodash or others?
Look, first of all, Reason has a first-class NPM support. That means that you can safely use any NPM module. You will probably need to write some typings so it will type properly. But this is the first part. The second part. I know that you have feeling that usually using the transpiled language drops a big mud of the code to bootstrap that transpiled thing. Reason is not about it. Since it uses module by module approach, all you have, like I demonstrated that for left pad thing, it will require parts of the standard library. This is a standard library of a Camel written in JavaScript. This is a part of Buccal Script. And after that, that will be all. This is the whole code produced, for example, by compiler. No bootstrap code, no nothing. This is how it works. It's up to you what you do next. I mean, this code after that should be taken by modular bundler, probably Webpack or Rollup. And also, it really plays nicely with things which are provided by such platforms like dead code elimination. So, for example, these modules are already split to separate parts, but they're effectively reshaken by Rollup, for example. And probably will be effectively shaken by the Webpack version 4, which improves support for pure modules. But this is the main idea. We do not put all the project in the one big ball of mud. Instead, we transpile to module by module with zero setup. I mean, this bootstrap code is like requiring that parts of the Camel standard library. And the last part of your question, a Camel has a pretty rich standard library, which allows us not to use some things like Lodash or so. But well, I have, for example, a use cases for Lambda or Lodash function FP in my project, and this is fine. Like I said, you can imagine that you are magically transpiling Reason file to the one JavaScript file, and after that it's all one by one.
Okay, thank you for your speech. I want to know a bit more about object-oriented interop with JavaScript. I mean, some libraries provide APIs with classes, and I need to inherit my user classes from their classes, and OCaml is a functional language first.
It has the object-oriented things. So yes, there are a few. I understand your point. There are some minor issues at the moment with doing an inheritance for non-ECMAScript 6 classes. I mean, done in the old prototype way. But in general, both Buccal Script is capable of generating classes as the output, and it is capable of taking classes as input. We had such scenarios. We were using the Google Maps library. And after that, of course, you have the escape hatch, like I told. You can say, okay, Camel, this thing, just execute this part of the pure JavaScript code and trust and treat the result as this type. So you need to explicitly write types. And that will work. And the one thing which helps a lot, it is a reasonably typed project, which provides a support to take existing flow type from the library for flow and dynamically generate reason type for that, exactly on that code. Also, Facebook, by the way, has, I don't remember exactly naming, it's a Reactive project. So if you have a project with pretty good strict typing in flow, it could be automatically translated to reason. And it will generally work and works nicely.
Okay, thank you.
Any other questions?
Thank you, Ilya. I have one question about tree shaking.
Yeah.
As far as understood, ReasonML can tree shake on the modules level with the help of rollup. Can it tree shake something smaller, like functions, classes, etc., etc.?
Yep. It can tree shake, it can pre-evaluate some expressions. For example, if it can understand that in this situation, this expression will be evaluated in that case. So yes, this is a capability of that. So it's not a part of the Buccal script, it's a part of OCaml. So Buccal script just do not care. It takes that OCaml provides, and OCaml is pretty good in that.
Thank you.
Okay, one more.
No one wants. Yeah, you can.
Отлично. Привет, спасибо за доклад. Да скорее не вопрос, а я хотел бы пояснения. Вот вы сказали, что из OCaml может транспилироваться в JavaScript, при этом JavaScript может быть, с точки зрения purity, не совсем purity, скажем так. Вот, и вот в чем вопрос. Если в OCaml, то есть вы сказали, что при этом код будет абсолютно безопасным, потому что в OCaml есть для этого проверка типов. Вот, но есть ли способ в OCaml в типах контролировать IO? Например, в Haskell у нас есть IO монад и вот всякие такие штуки. То есть не получится ли так, что IO, произведенное внутри OCaml, которое не учитывается в типах, произведет, грубо говоря, непотокобезопасный JavaScript?
Давайте на русском отвечу. Я понял вопрос. Смотрите, грубо говоря, в OCaml точно так же есть способы для выражения IO, понятное дело, как и в любом функциональном языке, и автоматическое появление IO в модуле автоматически приводит к тому, что он будет выведен как not a pure module. Все. То есть, вот эта штука, скажем так, она была разработана, это не часть Buccal скрипта, это часть самого OCaml, и она разработана лет 15 назад. И это, наверное, хорошая сторона, потому что есть мнение, что за 15 лет все баги-то повылавливали. Вот именно с определением purity, unpurity модуля.
Но у нас-то тут есть одна проблема, то есть мы получаем JavaScript код. Получается, что при композиции двух непure модулей мы в JavaScript можем получить выстрел в ногу или нет?
Нет.
Или это учтено?
Смотрите, то, что у вас, грубо говоря, вы и в обычном веб-паке, да, при композиции двух непure модулей можете получить выстрел в ногу.
Наверное, я не знаю, что такое веб-пак, мне просто интересно.
Хорошо,
с теоретической
в любом случае, как только у вас у модуля есть сайд-эффекты, теоретически они могут конфликтовать. Логично, правда? Да, то есть от этого никак не защищается. То есть вся фишка только в том, что можно сгенерировать код, грубо говоря, с меньшим количеством проверок и более расслабленный за счет того, что мы понимаем, что это чистый модуль, а изоляция этого чистого модуля — это уже на совести модуль-бандлера. Ну, в нашем случае я же веб-пак или
То есть если я заиспользовал какой-то аналог монады его внутри окамла, то сгенерируемый модуль будет отличаться от того, который бы я получил,
может отличаться, то есть не обязательно будет, в зависимости от того, нашел ли что окамл оптимизировать, это Buccal Script в данном случае уже, но да, может.
Понял, спасибо за ответ.
Any other questions? You can join Ilya in the expert zone.
Yep.
Let's thank you, Ilya, for this speech.